Hello, my little pre-calculus kids, and welcome. Oh, look, another announcement. Yay. It is the end of another day, and so I thought we would try this again. We're going to try a little bit different format today. I have the notes already written down, and I'm just going to kind of go through them with my awesome pen pointer here. So, power functions. Power. But anyway, power functions take on this type of shape or this type of look, and then the value of A will determine the type of and therefore the shape of the graph, whether it be in quadrant 1 or quadrant 4. We'll get into that here in a little bit, but if you will notice that if we have values of greater than 1, so like your squaring and your cubing functions, here's a squaring function, here's a cubing function. If we have values of less than 0 are reciprocal functions, and they're going to look like so. And then you have square root functions, which are looking like so, and then cube root functions, which look like this guy here. One thing that I do want you guys to notice, as a matter of fact, I'm going to turn Yo-Yo Ma down here just a little bit. If you can hear him, great. If you can't, that's okay. This is an even function, an even power. Notice it doesn't go down into the negative realm. Why? Because you can't take a negative number, square it, and get a negative number. Square root, same idea. When you get into reciprocal functions like 1 over x squared, this guy right here, something special will happen to him, and we'll figure that out as we go along. So, will we only be graphing these functions in quadrant 1? Absolutely not. We're going to be looking at them in other quadrants as well. As you can tell up here, I've gone ahead and drawn them. So let's move our way right down into the nuts and bolts of everything. Here are the four types that we have. We have 5x to the half, negative 2x to the negative 3, 2/3 x to the 4/5, and then negative 1/2 x to the 7th. Radical function, because it's a proper fraction. Rational function, because it's a negative. Radical function, once again, we have another fraction here, which consequently it could be improper as well and still be a radical function. And then polynomial, because once again we have a non-negative integer. So, what quadrant? Part B, where does the graph begin? Quadrant 1 or 4. We see that A is positive, so we're going in quadrant 1. A is negative, so we start in quadrant 4. 2/3 is positive, it starts in quadrant 1. And A is negative 1/2 here, so we're going to start in quadrant 4. For those of you who don't know what I'm talking about, real quick, this is 1, this is 2, this is 3, this is 4. But hopefully we've seen all that before. 1, 2, 3, 4. It goes counterclockwise. Why does it go counterclockwise? Ahaha, you will see. You will see. Finally, is this odd, even, or neither? It's neither. If you notice, there is no symmetry whatsoever. If I flip it, if I twist it, if I spin it, we can't pull it, we can't bop it, so to speak. Next guy, we'd see that this is an odd function. It does have a symmetrical line here, y equals x. This is an even function because it has a symmetrical line here at x equals 0. And this McDuder here, once again, we have an odd function. There is symmetry there. There is also, along with it being along, we do have rotational symmetry. If we were to rotate this 180 degrees, we would end up with the same thing. So, rotational symmetry is your odd functions, and vertical line symmetry is your even functions. So, and if you'll notice, here's my guy, here's my parent function, negative 2x to the negative thirds, so here's my negative 2x to the negative thirds, here's my parent function. Notice my parent function operates in quadrant 1 and 3, because A is negative, it reflects, so now I'm operating in 2 and 4. Is that always going to be that way? Yes. Is it always going to be that way for odd functions? Yes. Does it matter if the power is negative? Absolutely not. If this was a cubic function, then it would start in 3 and go to 1. If the 2 is negative, it starts in 2 and goes to 4. So any odd function is going to operate in 1 and 3, and then its reflection will operate in 2 and 4. Every even function, this is, well, it's not really a good example of it, but any even function, as you can see here, we have an even power. Yes, we have an odd radicand, but we do have an even power, which means that x can never be negative. So what we have here is a vertical line that splits it in two, that if I were to fold it in half, it would give me the same thing on either side. So the first thing I'm going to do with this is, this is actually x equals, or x to the 1/5. This is x to the 1/5 here. And then you'll notice when we said to the 4/5, x can't be negative, so we take just this part of it and we reflect it over the x-axis. So now we take it and we sort of bend it or twist it upwards, making this sort of, you know, the stick figure seagull that you drew when you were in elementary school art class. And then finally we have this guy. Parent function goes like so. And negative half, you know, we're going to be going down in quadrant 2 and then finishing going down in quadrant 4. And that's how those will go. And that's how they're all going to go. That's how they're all going to operate. Odd radicands will go, you know, will operate here and here. If it has an even power, you will spin that quadrant 4 or that quadrant 3 into quadrant 2. Odd functions will operate in 1 and 3. Even functions will operate in 1 and 2. Their reflections, the reflections of even functions, will operate in 3 and 4. And odd functions will operate in 2 and 4. So that's pretty much how that goes. You'll be turning the page over and noticing that this is blank. This is what we will be doing in class. Feel free to get started, and we can definitely help you fill in those blanks. What I want to do is I want to move on to factoring polynomials. And as you can see, there are 4 types here. I'm assuming that what they mean is that inside this is 2-term, 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 or 2-term, 2-term, 3-term, and 4-term. So first thing we got to do is always look for greatest common factor. So we factor out of x to the 4th, we factor out a negative 7y, we factor out a 4y, we factor out a 3. We're left over what's in red. And what's in red is a 2-term, a 2-term, a 3-term, and a 4-term. So when we do that, we've got 4 basic methods of which we do. So let me pull these off real fast, and let me actually take one of these guys here, so that way we can kind of divide and conquer, so you're not getting too overwhelmed with all the stuff. We can look at it from just one at a time. So if we start with difference of 2 perfect squares, x to the 4th, x squared minus 16. So we end up with x to the 4th plus quantity of x plus 4 plus quantity of x minus 4. All of these are factors. You can multiply them, put them back together, and you will get that. And apparently, we have a need to get a hold of everybody in the building through the PA system. Okay, moving on. The next topic is this guy, the sum and difference of 2 cubes. You'll notice the sum and difference of 2 cubes is right here. Notice it says plus or minus, then in here it says minus and plus. The plus correlates with the minus, and the minus correlates with the plus. And the plus correlates with the plus, and the minus correlates with the minus. There's cool little mnemonics that teachers teach you. I don't do that. You have to internalize how it works and how it functions. The whole thing of same sign, switch, whatever, and then always positive. Too many people remember how that is, but don't remember what it's for, so I'm not going to worry about the mnemonic. But negative 7y leaves me with y to the 3rd minus 8. So I end up with y minus 2, cube root gives me y minus 2, and it leaves me with y squared plus 2y plus 4. So square that term, gives me plus 4. A times b gives me a 2y, and since I'm switching the sign, since we have a minus, we have a positive in here. The reason for that is because, once again, we're multiplying. So when we multiply, we need things to divide, or I'm sorry, we need things to add to be 0. We need the additive identity. So that means I have a positive times a negative. I'm sorry, I got that backwards. A negative times a positive. In which case I will have a positive times a positive. So negative times a positive will give me a negative, and then a positive times a positive will give me a positive, and those two will give me the additive identity of 0. And we need that to happen when we're factoring these things out. I can show you how to do all that stuff by hand, factoring all of this by hand, but you'll get a better idea of it when we do difference of two cubes and stuff like that through synthetic division. But and like I said here, sometimes factorable, but not always. This guy is sometimes factorable, but he doesn't have to be by any means. Okay? The next one is the factoring problem, your typical trinomial. You should end up with an answer of 4y, x minus 3, 2x plus 1. How did I get there? I got there by doing this. 4y, and I have 2x squared minus 5x minus 3. So I factor out what I have in common here. I group the first, I multiply two outside numbers together, I get -6. Factors of -6 that add to give me -5 are -6 and +1. So I group them together and say, okay, what do we have in common? These two have a 2x in common. I'm left with x minus 3. What do these two have in common? A +1. I'm left with x minus 3. So I have 4y, x minus 3, 2x plus 1. And that's the factors of the above problem. Rewind. 3 times the quantity, 3x cubed plus 5x squared minus 4x minus 20. So here, we just have, once again, we factor by grouping. So I factor out my 3, and I group the first two together, I group the second two together. I'm always going to keep the sign with the number, so keep that negative with the 4. I put a plus sign in the middle because adding a negative is the same as subtraction. When I do that, I end up with 3, and then I have, what do these two have in common? An x squared. What do these two have in common? A -4. What's left over? X plus 5. This guy right here is not done. It's the difference of two perfect squares. So 3 times the quantity of x plus 2 times the quantity x minus 2 times the quantity x plus 5. So I put it down here in brackets so that way you can see what we're talking about. But all 4 of these are factors of the original problem. And so there's your 4 factoring methods. You'll notice it says now you try, and then those will be done when you walk in tomorrow. And then we have factoring stuff. What we're going to do in class tomorrow is we're going to work up to page and including page 14, so that we will be completely done with factoring. I hope this was helpful. Please go back and look at it over and over again if you need to. Come in with your questions. I will see most of you, well, not most of you, but I'll see a good number of you tomorrow during hot lunch. Remember, hot lunch A. Be nice to your parents, and eat your leafy greens. Make sure you drink lots of water. Don't cuss at Grandma. Have a wonderful day. Bye-bye.